We're recording. We're live. Let me pull up my
Live
notes.
in 5.
Okay. All right. So the topic is writing reusable code, and this is something that Corey suggested that I go through. And I guess to begin, um, I think we should establish what we mean by reusable code, because it means two things to me, and it probably means more things generally, and probably different things to you guys. When I think of code reuse, I think of, first of all, writing general purpose code, code that is reusable, and I want to spend a little bit of time talking about the theory of writing like more general purpose code and stuff like that. And stuff I think you guys have been exposed to, but it would be cool to just have a conversation about that. And by the way, I think this is going to be, my Docker presentation was much more of a presentation. I had a slideshow and everything. This one I think is going to be a little bit more interactive, in part because I haven't had a ton of time this week to like really prepare something completely put together. And I also think it'll be good to adapt our conversation as we go through. The second thing I think of when I think of code reuse is creating packages for other people to use. So I want to touch on both of those things. I'm going to start with the writing general purpose code theory and point you guys to some resources. But then I will show you I will show you how to like create an npm package. It's quite easy, so that you know how to create code that can be reused and installed and reused by other people. And then finally, I want to wrap up by looking at code that we reuse and talking about my thought process behind, because I created a number of those things like the model services, the API services, the API filter class. Time allowing, we'll look at the video game engine that I built for Hope for Henry, and some of the patterns, the code reuse patterns I use within that, and stuff like that. So that's my plan. Before I dive in, though, I want to ask, first of all, what questions do you guys have about code reuse, and is there another type of code reuse that you'd like to talk about here? And I'll just try to hit those as I go through other stuff.
My first thought is the general thought pattern of designing your code. I think sometimes I get caught up a little bit too much in the details up front, and it doesn't always work out that way. So my general strategy when I'm trying to write a good code is I just kind of start with the basics, and I take like iterations over it until it starts to like become clear. But I'm curious to hear like what is your process when you're kind of trying to design like a really good code base, right? Um, and just kind of the steps you take and where you start and how you iterate over that to ultimately land in the place where you're like, yes, I made a clean, reusable code.
Awesome. Yeah, I wrote that down. What other questions? We'll definitely hit that in the theory part.
So there's like principles that I know, like a function should only do one thing. Don't repeat yourself. Keep it simple, stupid. Like, these isms, that this wisdom that I have. But my challenge has been keeping code simple and reusable as requirements get tacked on. Like I'll think I've written something to be reusable, and then something will come up, and it's like, oh, my code's not set up to handle this. So now it becomes just slightly janky, but that slight jankiness I've added has sort of like defeated the thought that I maybe have put into how clean the code I've written is. Like an example of this is the Changers gamification system. I tried to write that so that it would be agnostic of the boosters that we were used in the system, but I was not successful. So it actually ended up adding some complexity because I tried to write it generalized first, and it just didn't work out. So I had to go in later and add like that specific code to meet my requirements.
Yeah.
So
That's great. Yeah, I think I'll say one thing to that, and then we'll definitely come back to that in a little bit. And that is Martin Fowler, who's he wrote the refactoring book that I lent to somebody. I think it was to Joseph, and he has a great blog. He's been blogging since 2000, I think, like that, or somewhere around there. And he's coined a lot of terms of art that we use in software engineering, and said a lot of pithy things that a lot of people repeat. Anyway, one of those things is that all software has essential complexity to it, because with software, particularly business software, you're trying to you're trying to model the real world in some way. And the rules of the real world are essentially complex. And as much as we'd like to try to reduce things down to like a pure, simple mathematical model, sometimes they are not reducible. And it's those edge cases that come up that blow things up. And I had one or two examples that I was going to show. One from Manager this past week where I encountered that kind of essential complexity. I had this beautiful function that I had to change. It's frustrating because you feel like it's a blemish on your code, but when you really kind of like step back to think about it, you're like, well, that has to be there. There's no other way to accommodate this need from the business side in the app. And so, yeah, so you definitely encounter that stuff. What other questions or thoughts?
I think just looking at examples would be awesome. I'm sure that's what you have planned, but yeah.
I'm gonna start with theory, but I then want to try to be as practical as possible. I know I have a tendency to wax a little philosophical. I've gotten that feedback, so yeah, we'll try to dig into that.
Cool. Yeah, like for example, I was never writing my Stripe components in a reusable way, and then I saw how Corey wrote a Stripe component for like a separate Django app, and I was like, oh, that's genius. And so just seeing that pattern made me like write more reusable code.
Yeah, that actually reminds me of a technique we can talk about. Okay. What else? All right. Well, feel free to interrupt me if you have any thoughts or you want to ask me a specific question about what I'm talking about. So, like I said, I think of code reuse in terms of writing general purpose code, and then the more mundane or common thing, which we all do, which is reusing packages of code. And I think the interesting thing, we'll talk about a number of different kinds of theory, but one of the interesting things about like using packages of code is the notion of encapsulation. And because our languages that we use, both JavaScript and Python, have modules, both of them have sort of this built-in encapsulation. But there are other ways to encapsulate code, which you've come across probably, like classes and functions. So when you think about writing reusable code from its foundations, it's all about those units of organization in the code, right? And those are the options available to you. And this may seem like a no-brainer, like yeah, obviously those are ways to group your code, but I think that as you think through it, there are different strengths and weaknesses to grouping code in certain ways, right? And you may have all been somewhat exposed to the big debate over functional programming versus object-oriented programming. That is fundamentally a debate about the most effective way to organize code. So one thing that I like to say a lot is that you should get your data right first. And this kind of goes to Joseph's question about process. Get your data correct first, and the rest will follow. And I'll try to express what I mean by that without like getting too crazy or philosophical. But like at its core, programming is a form of algebra, right? You define variables, and then you reuse those variables throughout your app. So if you think like some of the most basic algebra that you do, maybe I'll share my screen and we can kind of look at this. And you all took algebra at some point in your educational career. This is being slow to come up here. Let's put it on screen one. I think it's helpful to kind of start with thinking about, there we go, thinking about like mathematical operators and the types that operate on that. Okay, here we go. So for example, can everyone see this? Okay. Let's take for example like the idea of adding, right? Every programming language has a plus sign. This under the hood is really just like an alias for something like this, where you can take multiple arguments. Maybe you can take like A, B, C, D, right? That would add those together. Although usually, you know, with the plus thing, you really just have a left-hand thing, like A, and a right-hand thing, like B. And then if I chain these, I end up with that, and I have add A, B, and then I have C, right? And this extends to other operators, and I can throw a divide in here, and then suddenly, you know, the rules of math kick in, the order of operations and stuff like that. And so that composes to, let's see, it's C over D, so it's divide, we'll divide C by D, and we get that. So there are a couple, like, even in this like dumb, stupid, simple example, there's some complexity happening in here, and there's some really interesting concepts that are starting to arise. One is that, like, A, B, C, and D have they have a type. Like, add and divide wouldn't work on strings, not as well. They wouldn't work on objects. They wouldn't work on array. Now I know adding the plus in most languages like JavaScript, you can do hello plus world, and that becomes a concatenate function, right? And scripting languages get weird with how they coerce types and stuff like that. We'll gloss over that for a second. Let's just talk about, like, just operating on numbers. Because these are of a uniform data type, we can invent functions that are highly composable. They work together. You can combine them very easily. You know, these are things that are sitting in the back of your brain from like, you know, middle school math classes or whatever. But, you know, this is a pretty profound concept, that that you can have these operators, these functions that you can string together like this in a really terse syntax with very, very limited number of characters, but you can get a lot of functionality out of this. And then actually under the hood, you know, they used to call computers adding machines. Division, multiplication, and subtraction are all achieved by some sort of adding together of the bits and bytes. So it's actually, at the very bottom of everything, it's actually just a bunch of add functions, which is really kind of crazy to think about. It's just add functions built on top of each other. So I guess the two concepts I just wanted to highlight here is the power of uniform data types. If you have uniform data types, like these are all numbers, then you can write functions that do different things to those uniform data types, and those functions can be put together either in a string or side by side or something like that, in very interesting and sophisticated ways. So that is, like, I think really, so then power of uniform data types, and then the power of function composition. So let's go a little bit further with data types. Does this make sense so far? Are there any questions about, like, these two statements?
This is awesome. So super quick aside, I was working in Canary with some of the UI, like Melissa was doing this too back in March, and I was like trying to make this thing that was like basically trying to make some complicated functionality, and William said, well, make sure your data types are consistent. And I was like, what? That's sort of random. Like, that's not what I'm trying to do. I'm just trying to, like, do this thing. But then after like a couple hours, I was like, oh, he's totally right. Like, I need to be using a consistent data type, and that I don't like 100% grok it yet, but like I think I feel like you're totally right, and I like want to like continue to experience this for myself.
Okay, so. Awesome. Yeah, and we'll and I'm trying to. I think, you know, this is a common pedagogic technique in programming, I guess, is to come up with these really pithy phrases that kind of stick in your head, because someday, you'll be doing something like that, and you'll be like, oh, this is totally what that phrase means, and this is totally how I can apply it in this context. Any other questions on this so far? Okay, cool. So the next pithy phrase is, let's kind of set that aside. Program to an interface, and this is not mine, but it's something that people say. So what is an interface? For those of you who use TypeScript, Perry, you'll know that an interface, or have used Java, or I think C++ also has interfaces. An interface defines the shape of an object without defining a class, or without actually instantiating that object. So we could have a interface user, which is kind of funny because it's like user interface, and this could have a first name. And if we were working in a strongly typed language, we might say that has type string. They'll have a last name that has type string, and this is pseudocode.
This is Python TypeScript.
This is kind of like Python TypeScript. They have an age, that's an integer, unless you really want to have fractional ages and stuff like that. Maybe they have a date of birth, and that is a date time, right? And so what are we doing here? Like, well, we're defining this as a unit. This interface that we're defining is the shape of a whole new data type, which in functional programming sometimes is referred to as a record. Like an instance of this, we could create a record, user equals, let's use object literals, right? First name, William, last name, you get the point. Age, I'm 25. Date of birth, September 24.
You got the year right?
What's that?
Oh, let's see if you get the year right.
No, I'm not gonna put the year in there. No, I'm just kidding. I'm not sensitive about my age. 1987.
Oh, no,
there you go. There you go. Now you all know.
Do the math to that.
So anyway, you get, and actually this is probably not appropriate for a datetime like it would in Python syntax, or let's do JavaScript. We're just going to switch back and forth between languages. 2020, it's 2020, 924, right? So what we've done here is we've created a definition of a new type. So when we talk about like the power of uniform data types, I want to stress that like there are the primitive data types, strings, integers, technically you could call like date's not really primitive, it's more of an object and stuff like that. But then there are these more complex data types that you build up from them, right? So like arrays are a more complex data type, records and objects are a more complex data type, but these can also be uniform. Anything that implements interface user has the same shape as any other user. And we can start by saying like this is what I call, this is my phrase, a bag of data, right? Like this is just a set of data or a record, right? But we can also, in object-oriented programming, we might also add methods. So we might have the get fullName method, right? And this returns, I don't even know what language I'm writing anymore. This.firstName plus a space. And we have this on a lot of our Django models. And this probably will look really familiar to the Django developers because like when you define a data model, this is essentially what you're doing in Django. And I think that's one of like the really great things about Django is that it forces you, this was the other phrase I wanted to write down. Get your data right, or rather start with your data, get your data right, and the rest will follow. Django forces you to start with your data. You really can't do anything until you have data models. And then you have to build up your models in a really structured way. And that is why, that's a big motivator of why we built out the model services for our front end, because it also kind of forces you to go through that thought process of, okay, how is this thing going to be structured? How is it going to mirror the data that I get from the back end? And that is the root of code reuse, is having consistent data models that you can then pipe through various functions and stuff like that. So I'll finish this out. Let's do another example. So this is, when I say program to an interface, I just want you to kind of have this visual in your head of this is what I mean by an interface. It's like once I have an instance, like user, when I do user dot, what options are available to me after that dot? That's essentially what an interface is in practical terms. And if this is consistent, we'll look at ways to make that consistent. Actually, let's look at that real quick. So for instance, we have a higher level interface on the front end, like interface model. An interface model has a toAPI method and a fromAPI method, and also a create method, right? Create. And I won't define those. But that's part of the model interface. And so then anything that inherits from model, like say our interface user, is also going to inherit that interface. So this implicitly becomes a part of this model. So now anything that also has the model data type as its parent also has this consistent interface. So anything that could operate on a model, any function that could operate on a model, you could swap in another model and it should still work, as long as it's not straying from the interface of the model data type. So again, that is a method of getting code reuse. And what I would say here too is that like we may want to define, we may want to. Go ahead.
What language is this? Inherits from?
Just roll with it. Something that I prefer to do too is again, this is about composition, like combining different things, is to define user separate from model, and then define a third type interface user model that is a combination of the two, and this is usually called discriminated union. So usually use like the OR operator, the vertical pipe as the OR operator, and these two things together create the user model. I prefer this, and you'll hear people say a lot prefer composition over inheritance, and this is a practical example of composing two things rather than inheriting from model, because user is still a thing separate and apart from model. It can still be used separate and apart from model, but then we have an explicit thing that combines the two that we can use when we need that too. And so, you have the best of all worlds when you combine things rather than inherit from things, which forces you then to always have model as a part of your user, and sometimes you may not want that. So it gives you more flexibility. Yeah.
Is that what Django does in the backend that we don't see when we do a many-to-many relationship? Because there is no such thing as a many-to-many relationship in the database, right? Without creating a join table that constructs the two together with two primary keys that it connects.
Yeah, it creates a data type called a many-to-many relation. That's the name of the class, and in terms of the schema, it creates that join table. I'm not sure that answered your question though. It doesn't really create a new data type.
Like it wouldn't just be say a new table that it connects to that's called say user model, because of those you've got. Yeah. So
yeah. Sorry, go ahead.
No, that's I was having trouble when I was building some SQL tables that I want to do like for an architecture for a manager, and I was trying to figure out how to do a many-to-many, and it kept saying like you have to build a separate SQL table that is like an array table or something, and that you combine both models into that table, or two tables into that table, so you can get to use many-to-many relationship.
Yeah, I think the table is called something like, if it's the user profile image table, well, that wouldn't be many-to-many. Maybe it would be. Or like the user images table, it's like user underscore images, so that's, yeah, but that kind of strays a little bit from this, because I wouldn't necessarily call that, well, I guess that is a different data type, right? It's like the user profile image. You could also have profile image attached to events or something like that, or like some other model. So yeah, that kind of does create another data type there. All of this making sense so far? Any questions or comments to this? Okay, cool. I want to do another example, just kind of going back to like the algebra idea, right? With more, but combining that with the notion of a more complex data type. So in game programming, you often, if you're writing like a 2D game, we have an interface that is usually called vector 2, and everybody here has probably seen a two-dimensional vector like x, y, right? These are Cartesian coordinates that you'd plot on a two-dimensional graph, right? So interface vector has x, which is an integer, and it has y, which is an integer. Now, what if I wanted to create two vectors? We'll call them vector A and vector B, and add them together, right? Well, the way this works under the hood is that you would do vector A x plus vector B x, and you do vector A y plus vector B y, and you can also do other operations on them and stuff. In Python, you can actually override the add method of a class. So you can say class vector2 def add, and hopefully this is getting practical enough, right? So like pass it itself, but then you pass it the other vector, and you can say, okay, I want to return a new vector2. So this is kind of recursive in a sense. It's referring to itself, right? And it's going to return a new vector2 data type where x equals self.x plus other vec.x, and y equals self.y plus other vec.y. Now this expression, this could be like our test up here, this will work. And it will add the components of each vector properly. And this is like a form of metaprogramming. You can do that. You can't do this exactly in JavaScript, but if we get to the video game example that I wanted to show you guys, I have done this in JavaScript by having an add method and then having a function that delegates to that add method. So I can say add, in this case add vector, and it expects vector, but I could also have like a generic like add object, and this takes in object 1, object 2, and its responsibility is to say, okay, object 1 add object 2. And you see how this has the same sort of interface as this. We're passing in other vector, and this manages to add those two things together. So this is a good example, like going back to the interface idea. That's kind of what we've done here, is we've created an interface where that thing implements add as a method, and this knows how to add this thing to another instance of this thing. So it adds this. In the case of model, I don't know how you'd add two models together, but suppose, actually a good example is on Savvy. I had a model for payment, and what would happen is when you're computing a loan repayment plan, you'd end up with a list of payments that all needed to be summed up at the end. And so I used this double underscore add feature of and I forget what these kinds of methods are called, these private methods that are specific to Python. Dunder, yeah, dunder, but I feel like there's another, but yeah, these dunder methods. I used the add dunder method so that what I could do is say sum payments, where payments, yeah, I cannot type today, where payments was of type list of payment. And again, I'm not using proper typing syntax, but so this is really cool. Sum is built into Python, and it uses the dunder method within, if that's provided by a class. And so by defining a special payment method that would add payment.amount, I was able to then send a list of payments into the sum method without having to do what probably you would think you would have to do, is like 4p in payment. You do like total equals 0, 4p in payment, total plus equals p.amount. You're saving yourself a couple lines of code, but what's more interesting about this is the consistency of the interface and the fact that I can reuse, without having to write some custom looping code, I can reuse a built-in mathematical function on my complex data type. So that is another example of the power of uniform data types. By overriding this method, I made it work the way that built-in integers in Python work. Built-in integers in Python, all primitives in Python, well, all data types in Python are actually objects. They all have like a wrapper around them. In Python, you have a string. You can do like string.join. You shouldn't have a method that you can call on a string, but in Python there are methods you can call on strings because strings are in fact an instance of an object, and stuff like that. So all data types in Python have these sort of meta dunder methods attached to them, and you can write your own, and I think that's a really powerful concept. Another one that you can write is the iter method, which works with iteration. So if I add an iter method and I use this in our TN reports thing, I think Nate has seen this. I wrote a custom iteration method. What I had in that was a work log collection, so it looked kind of like this. Log collection. And when you initialize that, you would initialize that with your collection of work logs, and that would be stored in a private collection, like that. What I did with the iterator is I wanted to be able to iterate work log collection by saying for log in collection. So all I did, I don't remember the exact syntax, but basically all I did was return the next, I think it was something like this, the next item in the collection, because collection itself is iterable. and I think this is the syntax in Python. I'd have to look back for iterating to the next thing. So I turned this, and I was able to turn my custom class, my complex data, custom data type, into an iterable, just like the built-in list data type of Python. So again, really powerful concept. Go ahead.
Yeah, that was really cool. And I actually noticed that we aren't using that in our collection manager on JavaScript right now. It's not a big deal, but if you iterate, you have to do, like, let's say I have a collection manager of FAQs. I have to say FAQs.list, like for FAQ in FAQs.list. And it's like obviously like a really small change, but like hypothetically we could do that, and then we could do for FAQ in FAQs.
Yeah.
Sorry, you had said before that in JavaScript it's obviously not possible. I'm not recommending this as a solution, but can you just do string.prototype and then what is it? I forgot what it was now. Equal, or just add a new prototype to the string method that does add or list or whatever you want to do with it.
I think so. I think JavaScript does have an equivalent of these dunder methods. I know, for example, like the toString method is a built-in. So like if you add this to a class in JavaScript, so like if you had like class user and you add a toString method to this, and this returns this.firstName, then later if you have an instance of user, you can do string user, and it will print out that user's first name because you overrode the string method. So JavaScript does have sort of equivalents to the dunders. I don't know off the top of my head if it has an equivalent to the iterable or not. But yes, you can do that. You can override the prototype of built-in data types or of your own data types. And essentially, when you use this class syntax, you're defining user.prototype.toString. Okay, we're at like 20 minutes, so I want to get to some practical examples. And I'm not sure. Let's see. I'm not sure I actually have all these on this computer, I'm realizing. So we'll see what we can do here. This is the ritual I have to do on Windows. Do you need me to zoom this in?
Just a little bit, yeah.
I'm actually not sure how to do that. This is the problem with Windows, and I don't have my other things set up right now. Okay, let me see if I can just change my display. Actually, you don't need to see this part. I'll bring it up in VS Code. Let's see what we have here. Let's talk. I think everyone's familiar with the model services and APIs, so let's start there.
Not Festy.
You don't want to look at Festy?
Now let's look at a newer one. I feel like that one there. Festy's just got so many things going on.
Okay, how about you want to do Canary?
Yeah, I like
or
Canary.
Manager. Actually, I have Manager on here, so let's do Manager. We'll close Festy.
Goodbye, Festy.
Didn't know. Oh, it's already open. Okay. Very good. Except it's not. You can see this is much less polished than last time.
Wait, is it treating it like an SSL server?
It does, yeah. It treats it as a remote server. I don't know why this isn't opening. I might need to close it over here. Let's see.
Your terminal treats VS Code as a remote server?
Right there on the bottom.
Yeah, because Windows subsystem for Linux is sort of like running in a VM on top of Linux. There we go.
Oh, I see.
Or sorry, on
Yeah,
top of Windows.
there, it says that it's on remote.
Okay. All right. So let's go into the services directory. I think you're all very familiar with this. So this is more about like talking through the decisions that were made here. Oh, that's sad. It decided to update. That's very frustrating. It just died, and it was like, oh, I'm going to update this.
Notepad++.
Yeah, that might be the fallback. This is hilarious. Great timing. Okay.
May update.
All right. We get it. This is why I tried developing on Windows for like 2 weeks and went back to Linux. All right. Let's get back into it. So, actually, we could also look at alert. This was Bruno overwrote it and wrote some custom code in here, so I'm going to open that up and we can come back to that. Let's see, what's a good one? Let's look at contacts. Okay, so a few things in here, and I would love to have your guys' questions if there's anything in here that like you've wondered about, I guess. So this is an interesting example of reusable code because it's not really reusable code so much as a reusable pattern of code, right? That then leads to reusability. So we've done a better job with this in our new version of the TN models library, which I demoed before, where we've actually created reusable things. For example, you can extend or you can inherit from the model class now, and that means that you don't have to write your own static create from API and toAPI methods, right? Those are just built in. Those are part of the interface of a model, so you get those for free, so to speak. And then the other thing that we've done in the new version of this is you can declare your fields as static methods, so you don't have to write these ugly constructors, which every time someone sees this for the first time, they don't like it, and I understand. So yeah, so like any questions about this? Or is this too mundane? Is this like something you guys already understand well enough and you'd rather I move on to something else?
I guess my main question is which I think is mostly answered, is like, can we, because this is sort of a repeated pattern that all of our services have, can we factor this out to make the interface a little bit less verbose? And I think the answer to that is yes, because I think like you have started working on that, and Corey and Perry I think are also working on that. So
yeah, that's right. And that reminds me, like a good, so you know, we frequently talk about good user interfaces, right? Like good user interfaces are intuitive and they do what you expect and they have low friction. Well, here we've created a good developer interface. I think a pretty good developer interface, and that is like once I've built out my model, and this is verbose, and we're trying to make this experience better. But once I have it, then I have user.api all of my API methods at my fingertips, right? And then I also have user.create, and this is predictable and intuitive to me because on my contact model, I also have contact.create, right? And I also have contact.fromAPI, toAPI, and so on. So this is that idea of programming to an interface again. I'll put that up here in the list of pithy things. Oh, there it is right there. Program to an interface. This is also what we mean by that. Like not only creating consistent data types, but creating an interface that is easy to remember and easy to use, right? When I call create, I don't have to pass anything into that. That was a design decision. The reason I don't have to pass anything into that, well, in this case I would, but in the new version we created, it does this, right? So it defaults to an empty object. And then this also defaults to an empty object. So you can call create without any parameters, and that makes it really easy on the developer. All they have to remember is create. And then if they want to feed it other options, they know what they need to look at the model to understand what fields are on that model, but then they can start, you know, adding names to their contacts or whatever else they want. But then all of these are also optional. So to invoke my methods on my models, I don't have to have a lot of ceremony around it. I only need to write what I need to write to accomplish my goal, and that is, you know, that's an important design decision that was made in the design of these model classes that I think lends itself really well to reusability. Like this idea that all of the models implement the same interface, they have the same methods on them, and that calling those methods is easy but also flexible. In the sense that like there's a lot of power if you want to take advantage of it, but if you just want to create a new blank contact, just do that. It's easy.
So, oh, sorry. Go ahead, Corey.
I was so in terms of like a development process, would you say that like you knew this was the interface that you wanted to stick on before you had finished the implementation details? So like you would go in and like just flesh out the almost pseudo code of this class, and you write like, okay, at the end I want to be able to do contact.create, and then you say, okay, well now I need to implement the create function, and then you like sort of you start at that. Is that what that means, programming to an interface? Like you start at that end product and you just work your way backwards to the low level details?
Yeah, I won't say it's always as clean as that, right? Like there's usually some back and forth, but yes, it's like making a mock-up to kind of prove out the concept. And this I've said previously was heavily inspired by Django, right?
Right.
And so I knew what I liked about Django and how easy and straightforward that interface was. So I started there in terms of my design decision making, and then I was like, okay, well now how will I accomplish this in JavaScript? That was the problem to be solved. But yeah, I knew what I wanted my interface to look like. I think fromAPI came later when I kind of realized, oh, I need like a deserialization function in here. That wasn't an initial part of my thinking. That kind of came about the more I was writing API methods. I was like, oh, it'd be really good to have something that cleans and instantiates an instance of my model class on the API side of things. And so then I said, okay, we'll have a fromAPI thing. And then later I was like, oh, we need a toAPI thing. And that evolved over time to be parameterizable, right? So that your toAPI method, again, this is not a perfect example, but like the toAPI methods that I write let you include fields.
Yeah, the patchable object.
Yeah, fields to include and fields to exclude, so that because we use patches, because we use patches on the back end frequently, we want to be able to change the shape of the model before we send it to the API. But I still wanted objects that were instantiated on the client side to have all the fields that we would expect these objects to have under all circumstances.
So I'm a fan of this structure. And Nate said something interesting the other day when we were having a chat. He said, like it's really cool that you got to go work at Surety because you got to go see like something, like we always do things in a think nimble way, and like it's cool to see doing it another way. And so like for me, this was like this is the design I want to go with. I use it in my own code, and I think it's just a great way to do it. I guess if it's in part of this conversation, can you explain what the benefit of the generator functions are that we're using in this
Yeah.
system?
So one thing that was important to me was to create sort of a suite of factory functions. What I think you called
Factory functions.
Yeah, and this is something that I wanted to share in terms of like resources to like dig deeper into this subject of code reuse. A factory function is a design pattern, and in I think it was like 1995, there was this big book that was released called Design Patterns, and that was in like the heyday of object-oriented programming, and everyone wanted to do object-oriented programming. Some of those things have stuck around though, and there's a good book by Adi Asmani. It's free. It's a website that has all of the patterns from that original Design Patterns book cast into JavaScript, transcribed into JavaScript. So it's very easy to relate to those design patterns. And I recommend, like, you probably won't use that as a reference. You probably won't be like, oh, I need to solve a problem. What design pattern should I use for this? What you'll probably do is read that book and then later have a problem to solve where you're like, I should use this design pattern. So I definitely recommend reading that book just to get that seeping in the back of your head, because it will be useful to you at one point. But factory functions is something that I use all the time, and essentially, and it's what you see in the Django ORM, like user.objects.create is a factory function, user.objects.create user. What a factory function does is it lets you do business logic at instantiation time. You could do that in your constructor, but you can only ever have one constructor. And if your business logic, a good example of this is on the registration page, I need a slightly different kind of user with fewer fields required and stuff than I need on my pages past the login wall, right? On the pages past the login wall, I want a full-fledged user. I want to know all their permissions and stuff like that. But if someone's just registering, I just need them to put in their email and their password and stuff. If I want to reuse my user model for those two things, then I probably want to create different factory functions different like validation functions that handle those sorts of things. So what I could do is have like a factory function that runs validation on the input data. So I would take the data out of my form, feed it into the factory function, have that validate, and then have that throw errors if the data is not valid or something like that. So yeah, so that's kind of the thinking about around factory functions. These are extendable. I can add more of these. If there are more ways that I want to create a new user or a new contact, I can add to this without messing with my previous ways of creating a new contact. And that gets to the question about like, how do you modify your code over time? And that's probably a deeper topic than we're going to be able to get into in the next few minutes. But I'll try to show on Manager an example of the thing that I did. Let me see if I... Any other questions in the meantime?
I just want to highlight that before we run out of time, I think it would also be really cool to see an example of reusability in terms of a component, like a view screen or a view component, or just things that we practically work with on the front end.
Okay, cool. Yeah, I think what I'll say to that is like, I separate components into two ideas. One is a pure component, which is reusable, and the other is what I call a view, which is kind of confusing because it's like Vue.js. But and you'll see that I've done that in our projects. I have a views folder, and then I have a components folder. There's no logical separation in Vue, but there's a logical separation in my mind, and that is what belongs in the components folder. And you know, this kind of diverges from this concept, but what belongs in the components folder is truly reusable components. Like this modal is a truly reusable component. It's basically a wrapper, right? This is a really good example of a very reusable component. It has these divs that then wrap a slot, and then in that slot you can throw whatever you want. I've seen some modals that implement multiple named slots, like header, body, footer. I think that's great too, because then you can, like, in the footer slot, you can stick buttons there and they get rendered in a specific way or something like that. This is a really good example of something that I think belongs in a component library inside of your code, or the components folder inside of your code, and then also belongs in like a general purpose component library that you might create an npm package out of, because this is so generic that you could use it in any project. Many projects, practically all projects, require a modal. Now navbar, depending on how this is implemented, and I haven't looked at this, feels to me like less of a component. And yeah, you can see in here it says leads, forecast, accounts. These could be made customizable, right? Like I could send in a list of the links that I wanted to have, and then that could be dynamically rendered inside of this component. But because these things are hard-coded in here, this is a manager-specific thing. And so I would call this a view, not a component. So I would put this in my views folder, usually. And it's like, so what is a view? A view is like, a screen is obviously a view because it uses multiple reusable components in it, but then screens may also have sub-views. Like this navbar is a view inside of another view, and views can be nested. But is that distinction clear, and is that a helpful distinction to you guys? What do you think of that?
Yeah, I would also like to add something that I saw that they did in Azure that I had never seen before, and that maybe they have that opportunity because they're using the component constructor method. Is that they had a base class for some of their components that they all their other components inherited from, and then extended, which was interesting to me because we do have a lot of times where we create components that really do start out the same, but we can make them reusable because they have a lot of separate they have like a lot of distinct features on them. But they did all share this base class, and we could just do a base component class that has like all of those components built into it, and then you just extend out from. I thought that was really interesting to see.
Yeah, that is interesting. So yeah, I'm going back to this process question. Another one we could look at is alert. We use this in almost all of our projects, and this was built as a general purpose alerting tool, right? And it's very, very simple. It just holds a container or just has a container that is invisible, but then when you add alerts to it, the alerts inside of the container are visible, and it exposes an interface through the plugin, which I think is in alerts.js, store.js. The interface is add alert, remove alert, and then the higher level interface, which you guys all know, is just alert.alert, alert.alert, which you can feed options about the alert that you want to create. And I'm actually not sure where that's defined. There's create. Here it is. So you can just see that alert is mapped to add alert, which is imported from store. And Bruno rewrote this a little bit. What I would say about this, like my process for creating this particular package, is I started with writing something. I wanted to write a very small alerting library in pure JavaScript, and I have that up on GitHub, and I can share a link to that. What's been great about that is all I've had to do is wrap that in other. I first wrapped it in Angular, and now I've wrapped it in Vue.js. Because it's written in pure JavaScript, it's very portable. So that's another thing I'd say as part of the process is like that's also the thinking behind the services library. Write things in the pure language. If they're going to have a lot of business logic and stuff like that, whether you're writing in Python or on the JavaScript side, see if you can write things in the pure language rather than in the specific framework, and then wrap it in the framework. And I think I would say that's one drawback of Django's approach, where when you write your models, and that's where all your business logic lives practically, you've written something Django specific, and you're going to have a really hard time ever moving away from that if you wanted to. And so, but that's a trade-off that we sort of accept. So you'll sometimes, maybe often, see me writing plain classes even in a Django project, and that is why. The idea is just like portability, and it's probably not necessary a lot of the time, but that's just where my mind goes when I write things.
And how could you port it?
Well, how could you port a model, or how could you port pure Python?
Yeah, I guess like one of the Python classes that you write. Like what would you port it to, or how would you port it?
Like Flask?
Yeah, you could move it to a different web application framework, or you can use it without loading Django. It could stand alone.
Right.
You could import it into another project, and use it verbatim. A good example, some good examples of that. Actually, yeah, I just wrote this class in Manager under lead, I think. Let me check with my branch here.
Was it for the nihilist?
This was for logging actions. And this is something that I know we've talked about having like a more generic way of doing this. So I created this submodule under lead.background, and in here I have a function called emit event. And I know you got to go, Nate, so I don't want to I know we got to wrap this up, but I'll just wrap up on this one. So I created this function emit event, and what this lets you do is give a name of an action, the user who took the action, and the object that was acted upon. And it's a very simple thing. And right now, all we do with the emitted event is we log an action against a lead. Now, when I was writing this, I started with log lead action. I actually didn't have emit event. But then I was like, you know what? I can make this even more general purpose. So let me give it a more general name. And again, thinking about my interface, I was like, well, what would be a really general way of thinking about events that we want to log? And I wrote it to that. So I started with leads as the object, but then I went even, more general than that. And I guess going back a little bit to the theory, we have a lot of classification systems in our everyday life, like a dog is a kind of animal, and a Cocker Spaniel is a kind of dog, and stuff like that, and it kind of branches out like a tree. So that way of thinking is very much like the programmer way of thinking when you're thinking about like your objects and models. So and naming things in particular. So when I was logging something, when I was logging an action, well, what is a more general kind of action? It's an event, right? And an event is not necessarily an action that someone took. An event could be anything. It's like a higher level classification for that. And so, in the name alone, I haven't implemented anything more generic than just logging lead actions, but in the name alone, I've opened the door to something more general purpose in the future. And I'd say that's probably a big part of my process, is looking for, this kind of goes to the don't repeat yourself sort of thing. If you see yourself repeating yourself, what you're doing is uncovering a pattern that is more general than the thing that you're working on, and you should really lean into that and explore that and see and like see if you can think of like, what is that higher level thing. In this case it was an event, but what is that higher level class of things that I'm actually building here when I'm building like these multiple specific classes, because I'm repeating myself, so they all must belong to some sort of super category or super class, and I should probably create that super class, because then I can have more flexibility. You know, again, sometimes when you're just under a deadline and you're trying to ship, it's not worth doing that, but sometimes it is, because I think you get compounding interest out of genericizing things, making things more generic. And here, so I've set up Manager to, in the future, implement a more generic event logging system, like we've kind of talked about. And I'd love to go through this consumer class, but we're out of time. Any final thoughts or anything like that? I'll share some notes when I have a chance to Coder Zone.
If you could, William, if you could just send me that that document you typed up. Yeah, and just like if you have any more thoughts specifically on best practices around writing components, that would be good. I'm working on the components library. I think it would be good to like collect these tips in a distributable way, and maybe also include some tips in the README of that repo. So
yeah,
that's just the other thing I would bring up.
Awesome. Yeah.
Gotta add me on code review, William. I want to take a look at the stuff.
Cool. Yeah, I mean, I'll shoot you the PR where I
That'd be
put
sweet.
this up there. Yeah. I was kind of rushing on Manager, so I skipped our code review, to be honest. But,
you skipped code review? You can't tell anyone you skipped code review, William, because you're undermining the integrity of our
code review. I reviewed it. No, I did send code reviews to Bruno and Perry, but then Bruno left, and so then I went cowboy. I'm gonna delete this part of the video.
Oh, you mean you tagged me?
I'm gonna delete the part where the did not. I'm just gonna be like, I did code review. Sorry, what were you saying, Perry?
You tagged me, I think. You didn't make me main reviewer.
I didn't make you the main reviewer. I made Bruno the main reviewer. Any other final thoughts? I definitely want to do the one-on-one with Nate, so I know he's crunched for time, so.
Yeah, last thing I want to bring up is I'm just sort of interested on feedback around dev lunches like this, where we are sort of, it's more interactive, and William is just like going through code and highlighting his process, versus like the Docker presentation where it was more of a lecture. Like I'm interested in the usefulness of different things like that. I lean towards things like this being more useful for me personally, just because I'm a more hands-on kind of person. So if anybody has any kind of feedback like that, please send that to, I guess, me or William, because we have a lot of dev lunches scheduled, and I think we're going to need some type of priority around which ones are actually important. So, you know, just trying to start gathering that.
Totally agree. Yeah. All right, cool. Let's call it there. Thank you, everybody, for your time. Hopefully it was
Thanks,
helpful.
William. This is great.
Thank you, William.
All right. Later, guys. We can just hang out here if you want, Nate, or we can switch.